Good morning, ladies and gentlemen. Happy Wednesday. I hope you are having a good week so far. It's been a short week, so hopefully things are going pretty well for you. I know yesterday we started working with inequalities, and hopefully that made sense to you. Hopefully your check and reflect went positive. If you have questions about your check and reflect or about the homework, please make sure to email me. That's just a better way to make sure that you understand it. Otherwise, you can check with your friends as well or watch a video. But here's what I want to warn you about. The lesson, this topic seems really simple and basic. And so a lot of you might get a little overconfident. And then at some point, we are going to get this point where it gets tough and confusing, and some of you are going to be like, whoa, what just happened? And it kind of smacks you. So please stick with me throughout the videos, even when they're not very exciting or they're boring. Just watch anyway, and hopefully that'll make a little bit more sense. And as we're going along, if you're just staying with me, it should go pretty smoothly. Okay. So let's get started with that today. Okay. I want to start with a little review. Inequalities greater than, less than, greater than or equal to, less than or equal to. Um, Solution for a linear inequality. Give me 5 values that would make this inequality below true. Well, one could be like 10. 2 times 10 is 20, minus 5 is 15. 15 is greater than or equal to 3. That would work. 20, 25, 30, all those numbers. Okay. How many solutions are there? Well, I know based on what I'm saying is that I have an infinite number of solutions. However, one is the important one, and that is what's the smallest solution for x? And that point is called the boundary point. Okay, how could I find the solution? Well, one of the things I want you to focus on is when you're trying to find the boundary point right there, is just to solve this inequality as if it were an equation. So I'm actually just going to replace the inequality with an 3 or with an equal sign and solve. So 2x minus 5 equals 3. I'm looking for the point where they are equal because it does say equal to. So let's look for the point that's equal to. So 2x minus 5 equals 3. Oh, I add 5 to both sides, and I get 2x equals 8. Then I divide by 2, and I get that x equals 4. So my boundary point is 4. Now, that's not my answer. That's just the boundary point. That's the lowest number that would work for the situation. Now, what is the significance of the boundary point? What's the relationship with the inequality? That boundary point is the smallest point that makes this inequality true. Now, how do I find that? Well, what does x have to be? X has to be greater than or equal to 4. Anything below 4 makes the inequality false and therefore not work. Finally, write the inequality that represents the solutions for x. On a number line, highlight the solutions for x. Be ready to share your number line with the class. So I know that x has to be greater than or equal to 4. Now, on your number line, here's the shortcut I want to show you. When you've got a boundary point like 4, just go ahead and put that in the middle. Just go there. And then if you want to, you can do one number below, one number above. I know x has to be greater, so it's going to be these numbers over here. And should I have a filled in circle or an empty circle on 4? Well, because of the greater than or equal to, this should be a filled in circle on 4. And therefore, everything starting at 4 and going to the right would make the inequality true. Cool. Pretty straightforward. All right, let's try one more time. Okay. Now, this problem, 948, that's the last problem we're going to do. We're just going to do 2 problems today. It's pretty straightforward, okay? Solving linear inequalities with one variable. If you want a kind of step-by-step process, this is it for you. It kind of does what we just did in a little bit more detail, provides a little more information. So some of you might want to take notes on this one. Be careful, though. This can get tricky. So let's focus on that. So 3 minus 2x is less than 1. Okay? Find the boundary point. So what I want you to do is I want you to pause and actually find the boundary point and see what you find. And then when you're done, unpause it and we'll check it. Did you actually pause it? Did you actually solve it? Is your answer true? Seriously, think about it. Plug it back in. Does your answer work? Do they all work? Really? Because I'm going to bet that some of you are wrong. Or maybe most or all of you are wrong. Okay, so here's the process. Here's the problem. Let me show you what you did. I love this part because if you and you're like, what? What are you talking about? What? Wrong? Because you didn't do it. See what I mean? Let's solve this here. Okay, so fine, let's solve it. -3 and -3, and I get -2x is less than, 1 minus 3 would be -2, and then I divide by -2 and divide by -2, and x is less than 1. Oh, okay, x is less than 1. That is my answer. Really? Well, give me a number less than 1. How about 0? 3, let's try it up here. 3 minus 2 times 2 times 0 is 0, and 3 minus 0 is 3, and 3 is less than 1? Really? Well, what about -1? -1 is less than 1. 3 minus 2 times -1 is less than 1. 2 times -1 is -2. 3 minus -2 becomes plus -2 is less than 1. So 5 is less than 1. What just happened? Now, here's what I want to warn you about. Um, be careful with just following a procedure. Sometimes you need to think outside the box, and you also need to check your answers. Okay, because in this situation with inequalities, there are some situations where things are going to get a little ugly or tricky or confusing. And so what I want you to focus on is a couple things you could do. Number one, what if I just said, let's solve this for the boundary point and say, hey, I want to find when they are equal to. Now you're like, whoa, but it just says less than. I know, but I just want to find the boundary point. So I'm just going to solve this as if it were equal to. Now, I do the exact same process. 3. Okay, and I get -2x equals -2, divide by -2, divide by -2. I get x equals 1. So when x equals 1, check it out. 2 times 1 is 2, 3 minus 2 is 1, and 1 is equal to 1. So if I was looking for that, I would go with that point. The boundary point is 1. Now, here is something that can guarantee that you don't run into the issue you just did. Decide if the boundary point is part of the solution to the inequality. If it is a part, indicate this on a number line with a filled-in point. Now, think of it. Your number line is 1 part of the solution. It is not. Okay, so I am going to start at 1, but I'm just going to put an empty circle on 1. Just that. Okay, so an open circle at the boundary point. Finally, to determine on which side of the boundary the solutions lie, choose a point to test in the inequality. Now, again, so you're like, why? That's what we mentally did, didn't we? We actually plugged in the value. So if you actually just find the boundary point, you're not going to run into the issue that we just ran into. Okay, so let's pick a point. Let's look at them. I have 0. I have 2. Now, again, I'm plugging it into here. 3 times minus 2 times 0 is 0. 3 minus 0 is 3. And that does not work. But what about 2? Does 2 work? If I have 3 minus 2 times 2 is less than 1. Oh, 3 minus 4. Yeah, -1 is less than 1. That works. So therefore, everything to this side gets shaded in. So that is an easier way to make sure you don't run into the issue that we ran into. Now, you're like, well, what is the issue? What happened? Why did that not work? Here's the problem. When I start changing my variables over, or when I divide by a negative, it affects the signs. It actually makes the sign kind of switch. So if I had, 3 minus 2x is less than 1, and I did, hey, plus 2x and plus 2x. What I have now done is I've changed the variable to the opposite side. At that point, I should have switched the sign. Or if I divide by a negative, that changes things to the opposite. So that would also kind of force the switch to sign. All those rules can get really confusing. So the easier way to do this is to solve for this as if it were an equation to find your boundary point. And at that point, you just need to stop and think about the problem and pick a value, plug it in to the inequality, find which side makes it true. One side is going to make it true, one side is not, And once you find the side that makes it true, you've got your answers. Okay. So, guys, that's it for today. It just a basic one-step inequality. Tomorrow we take two-step inequality, and so it will get more complicated tomorrow. For today, it's kind of foundational, and hopefully that made sense. Your homework is just problem 51 and 55. And again, if you want to pause and read Foxtrot, you may. If you don't want to, that's fine. Okay. I hope you do have a wonderful day. I hope you enjoy yourself and get some time outside. I will talk to you later.